Good morning, everybody. So, my name is P. Havappa, faculty in physics from Government Degree College, Narayankhel, District Sangareddy. So, today's our topic is for semester 5 students, final year of the semester students. So, today's our topic is electric potentials and electrostats. Electric potentials. What is electric potential? How can we find out electric potential due to uniformly charged sphere, due to point charge, and due to dipole? So these are the concepts of today concepts. So first, what is electrical potential? Electric potential is nothing but the work done per unit charge in electric field is called electric potential is nothing but V equals to W by Q naught. So units of the electric potential is volts. So electric potential due to a single point. So today's first topic is electric potential. Electric potential at a point due to a point charge. Let us consider isolated point charge plus Q at a point O, which is as shown in figure, and charge plus Q naught here at a point of P at a distance x from point O. So this one is x. So work done to displace the test charge Q naught through a small distance dx applies a force F equals to E into Q naught. By the definition of E equals F by Q naught, we can write F equals to Q naught into E against the direction of electric field. Then we can write dW, the work done per dx, that is dW equals to F into dx, whereas F equals to EQ naught into dx. Here E and dx is our opposite direction, that is cos 180. We can write cos 180 is nothing but minus. So dW equals to minus Q naught into E into dx. But only we know that E equals to electric field intensity at a point equals to 1 by 4 pi epsilon into Q by x square. So dW equals to, substituting E value in above dW, we can write dW equals to minus 1 by 4 pi epsilon into Q naught by x square into dx. Let us assuming the test charge Q naught at a point A, which is distance from O, infinity distance from O, move to point B, which is a distance of r from O. Then the work done for this movement can be obtained by integrating above equation of dW. Hence W equals to minus integral of dW, that equals to minus integral of 1 by 4 pi epsilon Q naught into dx by x square. So hence we can substituting these values, then we can get W equals to 1 by 4 pi epsilon into Q naught into 1 by x from infinity to r. So substituting infinity r values, we can get 1 by 4 pi epsilon naught into Q naught by r. But by the definition of potential, V equals to W by Q naught. Substituting W value in this equation, we can get electric potential at a point due to point charge is V equals to W by Q naught, that equals to 1 by 4 pi epsilon naught into Q by R. So if RB equals R and RA equals infinity, then VB minus VA equals to 1 by 4 pi epsilon Q by R. Here V equals to 1 by 4 pi epsilon naught into Q by R. This one is electrical potential or electric potential at a point due to charge point. Okay, so this one is electric potential at a point due to charge point, that is 1 by 4 pi epsilon naught into Q by R. The next concept is electric potential and the intensity of electric field at a point due to uniformly charged spherical conductor. The next concept of electric potential is electric potential and the intensity of electric field at a point due to uniformly charged sphere. Let us consider the diagram which is as shown in diagram, whereas electrically charged sphere of radius of A with center O, radius of A, and plus Q uniformly spread in surface charge. Surface charge density can be represented as sigma equals to Q by area of the spherical conductor, that is 4 pi A square. Let us find out the electrical potential in the form of 3 cases. The first one, at a point outside the sphere, that is which is distance from R from the center, and at a point on the sphere surface of the sphere, that is distance A from the center, and at a point inside the sphere on the axis at a distance r1 from the center. So let us consider electric potential at a point outside the sphere, that is at a point of P. Let a point P outside the sphere at which distance r from the distance. So the sphere under consideration can be thought as a collection of rings. The sphere is having collection of rings. Here Mn is having a ring, and the charge of that ring is the radius is from limit to r minus a to r plus a. Let Mn be the thickness of the ring with radius y. Here this one y from the axis, and y a distance r from the point P. This radius point is r from the P. Next we can write potential at a point P due to Mn. So due to this charge is dV equals to 1 by 4 pi epsilon to dq by r. So from the diagram we can write angle NOP, here angle NOP and angle MON. So there are two angles and one triangle, that is PAN. So angle of NOP can be written as theta, angle of MON can be written as d theta. So from the diagram we can write y equals to a sin theta, then dy equals to a into d theta, and the triangle of AON. So here the triangle of AON, this is the triangle. So by this triangle we can write NP square equals NA square plus AP square, that equals to, already we know that NP equals to R, NA equals to Y, and AP equals to R minus A cos theta whole square. Substituting these values we can get dr by small r equals to a sin theta into d theta by capital R. So by using these equations we can write dV 1 by 4 pi into dq by r, capital R, 1 by 4 pi into 2 pi y into dy into sigma by r. Here also already we know that y equals to already we know that dv equals 2 pi a sin theta into a d theta into sigma by 4 pi epsilon into r. So substituting these values we can get dv, that is 2 pi sigma a by 4 pi epsilon into a sin theta into d theta by capital R into capital R. So to determine the potential at a point V, we can write integrating of this above dV from r minus a to r plus a, that is v equals to integral of r minus a to r plus a into dV. Substituting these values we can get the v value, that equals to 1 by 4 pi into q by r. The expression shows that the potential and external point of charged sphere is same if the total charge on the sphere is concentrated as a point of charge. at its center, that is V equals to 1 by 4 pi epsilon naught Q by R. Potential on the surface of the charge sphere, that is small r equals A. Substituting small r equals to A value. So in above equation we can get V equals to 1 by 4 pi epsilon naught into Q by small a. From the above expression, it is evident that electric charge is concentrated at the center of the sphere. And the third case, potential inside the charge sphere. Inside the charge sphere is nothing but let the P point be inside on the axis of a charged sphere at a distance r1 from the center of the center, that is r1 is less than a and r equals r1. There is the limits will be changed, that is a minus r1 to a plus r1, introducing and integrating dv with a minus r1 to a plus r1. So we can write v equals to 2 pi a sigma by 4 pi epsilon naught into r1. Integrating on both sides, we can get v equals to 1 by 4 pi epsilon into q by a is nothing but on the sphere and inside the sphere there is a same value of the electric potential. So diagram will be like this. From this equation, from this diagram, we can explain potential due to charged sphere with distance from the center. From a graph is clear between r equals minus a to plus a, the potential is maximum here. R equals minus a to plus a, the potential is maximum and varies inversely with the distance in the outside of the sphere. So intensity of electric field, already we know that by the definition of V equals to 1 by 4 pi epsilon Q by R, and the relation between E and V equals to E equals minus dou V by dou R. Substituting V value in above equation, we can get 1 by 4 pi epsilon into Q by R square, which is centric point of the charge, equivalent to centric point of the charge. Second case is on the surface of charged sphere, that equals to r equals to a. Then substituting r equals to, we can get 1 by 4 pi epsilon into q by a square. Inside the charge 1 by 4 pi epsilon into q by a, that equals inside of the charge there is no electric field. Therefore the electric field intensity is to 0 from inside up to the on the surface is maximum, and outside the surface is increasing with the increasing of spherical intensity decreases by the increasing of distance. So this one is electric potential and electric field intensity due to spherical charge conductor. The next one is electric field and electric field potential due to a line charge of infinity length. So here consider a line charge of infinity length, which is as shown in figure. Then the line charge density can be written as lambda equals to Q by L. Suppose P be the at a point distance here, P. This one is P at a point distance R from the line. So let us assume the cylindrical surface, Gaussian surface, with the radius of r and the length L coincide with the line of the charge. The electric field is represented at a very point normal to the curved cylindrical surface. So the electrical flux is only through the curved surface of the cylinder. So next we can write a charge flux, that is by the definition of charge flux phi equals to integral of E dot ds. Already we know that by the definition of linear charge density, lambda equals to Q by L, then Q equals to L lambda. Substituting these values, we can get E value 1 by 4 pi epsilon into 2 lambda by R, where 2 pi RL is the lateral surface of the cylindrical Gaussian surface. Hence we can write 1 by 4 pi into 2 lambda by R. This one is electrical field for linear charge density, linear charge conductor. Then electrical potential, already we know the relation between electric field intensity and electrical potential, V equals minus integral of E dot dr. So substituting E value 1 by 4 pi into 2 lambda by R in this above equation, we can get V equals to 2 lambda by 4 pi into log R plus A. The substituting calculating of A value, we can write where R equals to R naught, then V equals to V naught. So V naught equals minus 2 lambda by 4 pi epsilon naught into log to the base E R naught plus A. From this equation we can write A value. So A value equals to V naught plus 2 lambda by 4 pi epsilon to log to the base E R naught. Substituting this equation in V, we can get V value 2 pi by lambda 2 lambda by 4 pi epsilon to log to the base E R naught by R plus V naught. So let us assume R1, R2 are the two radius or two distances. Then the V1 can be written as 2 by lambda into 4 pi epsilon naught into log to the base R naught by R1 plus V naught, and the V2 equals 2 lambda by 4 pi epsilon naught into log to the base R naught by R2 plus V naught. So therefore potential difference that is V1 minus V2 equals to delta V, that equals to 2 lambda by 4 pi epsilon naught into log to the base R naught by R1 minus log to the base R naught by R2. Substituting or simplifying these equations, we can get V1 minus V2 equals to delta V equals to 2 lambda by 4 pi epsilon naught into log to the base R2 by R1. This equation explains potential difference of the linear charge conductor or the line charge conductor. So next concept. And the next concept is potential and electrical field at a point due to electric dipole. First we know that what is electrical dipole. When two equal and opposite charges, this one is electrical dipole, A and B. When two equal and opposite charges are placed at a points A, B, which are at an equal distance A from the center of point O, this system is called electrical dipole. Consider a point P, which is spherical coordinates r comma theta and r distance from the origin in the center of the dipole. Let the line PO here, this one, PO makes an angle theta with the axis of the dipole, then angle BOM equals to angle AON. So like this, AON equals to BOM. So next, now the resultant potential can be written as V equals to V1 plus V2 from the point A and from the point B. So first we can write a potential due to A, V1 equals 1 by 4% Q by a distance between these 2 points PA. So already we know that PA equals from the diagram R minus A cos theta. Why? Because there is a triangle of OAP. We can write PA equals to PN equals to OP minus ON, that equals to R minus A cos theta. Similarly, we can write V2 by using POB. So we can write V2 equals to 1 by 4 pi epsilon to minus Q by PB, negative charge. So substituting these two values in V1 plus V2, we can get V equals to resultant potential V equals to Q by 4 pi epsilon naught into 1 by R minus A cos theta minus 1 by R plus A cos theta. Simplifying this equation, we can get Q by 4 pi epsilon into R plus A cos theta minus R plus A cos theta by R square minus A square cos pi theta. Simplifying these equations, Q into 2A into cos theta. Why? Because Q into TA, product of charge and distance between 2 points, dipole element is nothing but P. So hence substituting these values in above equation, we can get V equals to P cos theta by 4 pi epsilon naught into R square. This one is potential due to dipole. So if there is a theta equals 90 degrees, is nothing but perpendicular bisector of the dipole, then there is theta equals 90 degrees is nothing but cos 90 becomes 0, then there is no potential perpendicular time. V equals 0, then the maximum of the potential, that is 1 by 4 pi epsilon naught into P by R square. So this one is electric potential perpendicular axis and parallel axis. On the axis, for perpendicular axis theta equals 90 degrees, there is no potential, V equals 0. For the 0, if theta equals 0, then the maximum of the axis of the dipole, that equals to V equals 1 by 4 pi epsilon naught into P by R square. Next, we are calculating intensity of electric field or electric field intensity by using above V equation. Already we know that relation between E and V, E equals minus dou V by dou R. Substituting V value and differentiating with R, we can write ER equals to 1 by 4 pi epsilon to, here E is a vector, then we can differentiate with two types. The first one is R and the second one is theta. For R, ER equals to minus dou V by dou R, then ER becomes 1 by 4 pi epsilon to 2p cos theta by R square or R cube, and E theta equals minus 1 by R into dou V by dou theta. Differentiate with theta, then we can get E theta equals to 1 by 4 pi epsilon into P sin theta by R cube. Therefore, the resultant intensity of the electric field at a point P can be written as under the root of ER square plus E theta square. Substituting ER, E theta values in this equation, we can get resultant intensity of electric field at a point P equals to E equals to P by 4 pi epsilon naught R cube into under the root of 3 cos pi theta plus 1. Why? Because here 4 cos pi theta sin theta. There is 1 cos pi theta, the 3 cos pi theta plus 1 cos pi theta plus sin pi theta. Cos pi theta plus sin pi theta, already we know that the equation of cos pi theta plus sin pi theta equals to 1. Hence, finally we get E value that equals to P by 4 pi epsilon naught R cube into under the root of 3 cos pi theta plus 1. And the direction of the electric field intensity can be written as tan phi equals to E theta by ER. Substituting E theta and ER value, then the ratio of the E theta and ER equals to tan theta by 2. Therefore, phi equals to tan inverse of tan theta by 2. These are the electric field intensity of the dipole and the electric potential of the dipole. So this one is today's our topic. So what are our topics are? So today's topics are, the first one is electric potential at a point due to point charge. So electrical potential at a point due to point charge is V equals to 1 by 4 pi epsilon naught into Q by R. What is electric potential? Work done per unit charge in an electric field is called electric potential. What is the equation of electric potential due to point charge? That is, the electric potential due to point charge is V equals to 1 by 4 pi epsilon into Q by R. And the next concept is potential and intensity of electric field at a point due to uniformly charged spherical conductor. There is a 3 points or 3 cases: outside the spherical conductor and on spherical conductor, inside the spherical conductor. For outside the spherical conductor, the value of the electric field intensity is 1 by 4 pi epsilon naught into Q by R. On the surface, 1 by 4 pi epsilon into Q by A. Inside the surface, that is 1 by 4 pi epsilon into Q by A. From this, we know that inside the surface and on surface is a maximum value, but outside the surface, potential increasing with the decreasing with the increasing of a distance from the center point. Where R equals minus A to plus A, there is a maximum value of potential, but minus R, here plus R, there is a minimum of R decreasing with the increasing of potential. Next, in the case 1, outside of the charge sphere, we can take E equals to 1 by 4 pi epsilon into Q by R square. On the surface, E equals to 1 by 4 pi epsilon into Q by A square, but inside the surface there is no charge, that's why there is no intensity. Minus dou V by dou R becomes 0. And the next concept is electric field and electric potential due to a line charge of infinity length. In this concept, we can find out, or already we found that E equals to 1 by 4 pi epsilon into 2 lambda by R, and V equals to 2 pi by 2 lambda by 4 pi epsilon into log to the base e r2 by r1. So this one is electric field intensity and electric potential due to line charged conductor. And the next concept is the last concept, potential, electric potential and electric field at a point due to an electric dipole. What is electric dipole? Electric dipole is nothing but when two equal and opposite charges are placed at a point, points A and B, which are at an equal distance A from the midpoint O. This system is called an electric dipole. By using this electric dipole, we found V value, that is V equals to T cos theta by 4 pi epsilon naught into R square. When the axis is point is perpendicular to the axis, then theta equals 90 degrees, then V becomes 0. When the point is on the axis, as parallel to the axis, then the maximum of V value will be occur, that is V equals 1 by 4 pi epsilon naught into Q by R square. So this one is electric potential due to electric dipole. Perpendicular direction, there is no electric potential. Parallel direction, there is a maximum of electric potential. Hence, intensity of electric field can be written as here E equals to P by 4 pi epsilon into R cube. Why? Because E is a scalar vector product. That's why in a polar coordinates theta and R, we can write E in a form of ER and E theta. Then E becomes E equals to P by 4 pi epsilon into R cube and the root of 3 cos square theta plus 1. And the direction of this electric field intensity is theta equals phi equals to tan inverse of tan theta by 2. So these are today's topics, very very important topics for semester 5, paper 5 of final year students. సో ఫైనల్ ఇయర్ స్టూడెంట్స్ సంబంధించినటువంటి వెరీ వెరీ ఇంపార్టెంట్ కాన్సెప్ట్స్ ఎలక్ట్రిక్ పొటెన్షియల్ అంటే ఎలక్ట్రోస్టాట్స్లో ఫస్ట్ టాపిక్ ఉంటుంది. సెమిస్టర్ 5లో ఉన్నటువంటి ఫస్ట్ టాపికే మనకి ఎలక్ట్రోస్టాట్స్, స్థిర విద్యుత్ అని చెప్పేసి అంటాం. ఎలక్ట్రోస్టాట్స్లో 2 పార్ట్స్ ఉంటాయి. ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ క్యాపిటల్ ఈ అంటున్నాం, అదేవిధంగా ఎలక్ట్రిక్ పొటెన్షియల్ వి అని చెప్పేసి అంటున్నాం. ఎలక్ట్రిక్ పొటెన్షియల్ స్కేలర్ క్వాంటిటీని కలిగి ఉంటుంది, అదేవిధంగా ఈ అనేది వెక్టర్ క్వాంటిటీని కలిగి ఉంటుంది. సో ఇందాక కాన్సెప్ట్లో మనం ఈ గురించి చెప్పాం, గాస్ లా చెప్పి అప్లికేషన్స్లో ఈ గురించి చెప్పాం. కాబట్టి ఇవాళ కాన్సెప్ట్లో మనం ఏం చెప్తున్నాం, పొటెన్షియల్ గురించి వివరించడం అనేది జరిగింది. సో ఎలక్ట్రిక్ పొటెన్షియల్ డ్యూ టు సింగిల్ పాయింట్ ఆర్ చార్జ్ పాయింట్, ఎలక్ట్రిక్ పొటెన్షియల్ అండ్ ఎలక్ట్రిక్ ఫీల్డ్ డ్యూ టు spherical charge conductor, electric potential and electric field due to dipole, and electric potential and electric field due to linear or line charge conductor. సో అంటే ఏకరీతి తీగ వల్ల ఏర్పడేటటువంటిది, డైపోల్ వల్ల ఏర్పడేటటువంటిది, అదేవిధంగా గోళాకారం వల్ల ఏర్పడినటువంటి విద్యుత్ పొటెన్షియల్ మరియు విద్యుత్ తీవ్రతకు సంబంధించినటువంటి వివరణ గురించి వివరించడం జరిగింది. సో ఇవి ఇవాల్వ్ కాన్సెప్ట్స్, చాలా చాలా ఇంపార్టెంట్ కాన్సెప్ట్స్ కాబట్టి అందరు కాన్సన్ట్రేట్ చేయాల్సి వస్తుంది. సో ఈ టాపిక్స్ అనేవి వెరీ వెరీ ఇంపార్టెంట్ టాపిక్స్ కాబట్టి ప్రతి ఒక్కరు కూడా ఈ టాపిక్స్ పైన కాన్సన్ట్రేట్ చేయాలి. సో ఇక్కడ లాంగ్ క్వశ్చన్స్ ఉన్నాయి. సో లాంగ్ క్వశ్చన్స్ ఉన్నాయి కాబట్టి లాంగ్ క్వశ్చన్స్ని అందరూ కంపల్సరీగా చదవాల్సి ఉంటుంది. కాబట్టి ఎలక్ట్రిక్ పొటెన్షియల్ అనగానేమి, ఎలక్ట్రిక్ పొటెన్షియల్కి సంబంధించినటువంటి అప్లికేషన్స్లో తీగ వల్ల ఎలక్ట్రిక్ పొటెన్షియల్, ఎలక్ట్రిక్ క్షేత్ర తీవ్రత ఏ విధంగా ఏర్పడుతుంది, అదేవిధంగా డైపోల్ వల్ల ఏ విధంగా ఏర్పడుతుంది, అదేవిధంగా గోళాకార తీగ వల్ల, గోళాకార ప్రవాహం వల్ల అంటే గోళాకార వాహకం వల్ల ఏ విధంగా పొటెన్షియల్ ఏర్పడుతుంది, దాని నుంచి మనం ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీని ఏ విధంగా రాబడుతున్నాం అనే కాన్సెప్ట్స్ అనేవి చాలా చాలా ఇంపార్టెంట్, లాంగ్ క్వశ్చన్ పర్పస్లో ఇంపార్టెంట్ కాబట్టి ఈజీగా స్కోర్ అయ్యే ఛాన్స్ ఉంటుంది. కాబట్టి అందరూ కంపల్సరీగా చదవాల్సి ఉంటుంది. ఎలక్ట్రిక్ ఫీల్డ్ పొటెన్షియల్, ఎలక్ట్రిక్ ఫీల్డ్ పొటెన్షియల్, ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ. సో వీటిపైన కాన్సెప్ట్స్ ఉంటాయి కాబట్టి కంపల్సరీగా 3 లాంగ్ క్వశ్చన్స్, 2 షార్ట్ క్వశ్చన్స్ ఉంటాయి. సో ఈ క్వశ్చన్స్ అన్నిటిని కవర్ చేసుకుంటే 3 లాంగ్ క్వశ్చన్స్ 2 షార్ట్ క్వశ్చన్స్ ఉంటాయి కాబట్టి 15 + 6 21 మార్క్స్ కంపల్సరీగా వచ్చే ఛాన్స్ ఉంటుంది. అదేవిధంగా కాంపిటేటివ్ ఎగ్జామ్లో కూడా దీనిపైన అడిగే ఛాన్స్ ఉంటుంది. ఎలా అడుగుతున్నాడంటే డైపోల్ వల్ల ఏర్పడే పొటెన్షియల్ ఏ విధంగా ఉంటుంది, వాట్ ఈస్ ద పర్పెండిక్యులర్ యాక్సిస్ వి వాల్యూ అండ్ పర్పెండిక్యులర్ యాక్సిస్ ఆఫ్ ద డైపోల్ అనగానే మనం ఏమంటాం 0 అని చెప్పేసి అంటాం. అదే యాక్సిస్లో సేమ్ యాక్సిస్లో తీసుకుంటే మ్యాక్సిమం వస్తుంది. సో లీనియర్ ఛార్జ్ కండక్టర్ నుంచి వచ్చినటువంటి ఎలక్ట్రిక్ పొటెన్షియల్ వాల్యూ ఎంత అంటాడు, ఎలక్ట్రిక్ పొటెన్షియల్ ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ వాల్యూ ఎంత అంటాడు. సో ఇవన్నీ కూడా చాలా ఇంపార్టెంట్ కాబట్టి ఈ టాపిక్ పైన అందరూ కంపల్సరీగా కాన్సన్ట్రేట్ చేయాల్సి వస్తుంది. సో ఎలక్ట్రిక్ పొటెన్షియల్, ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ అండ్ దెన్ applications of Gauss law and applications of electric potential in various charge conductors. These are the very important questions in semester 5. కాబట్టి స్కోర్ వచ్చే ఛాన్స్ ఎక్కువగా దీంట్లోనే ఉంటుంది కాబట్టి కంపల్సరీగా అందరూ కూడా ఈ కాన్సెప్ట్ పైన వీటిపైన ఎలక్ట్రిక్ పొటెన్షియల్స్, ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ, విద్యుత్ క్షేత్ర తీవ్రత, విద్యుత్ పొటెన్షియల్ పైన ఎక్కువగా కాన్సన్ట్రేట్ చేయాలి. కంపల్సరీగా డ్యామ్ షూర్గా లాంగ్ క్వశ్చన్స్ వచ్చే ఛాన్సెస్ ఉంటాయి కాబట్టి సో లాంగ్ క్వశ్చన్ ఒకటి వచ్చినా 15 మార్క్స్, షార్ట్ 2 వచ్చినా కానీ 6 మార్క్స్ అవుతాయి. సో 15 + 6 21 కాబట్టి మళ్ళీ ఈజీగా పాస్ అయ్యే ఛాన్స్ అనేది ఉంటుంది. సెమిస్టర్ సిస్టంలో పాస్ అవ్వడం అనేది చాలా ఈజీగా ఉంటుంది కాబట్టి కంపల్సరీగా డ్యామ్ షూర్గా అందరూ సెమిస్టర్లో పాస్ అవ్వాలి అంటే ఈ టాపిక్ పైన ఎక్కువ కాన్సన్ట్రేట్ చేయాల్సి ఉంటుంది. కాబట్టి అందరూ కంపల్సరీగా ఎలక్ట్రిక్ పొటెన్షియల్, ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ, అప్లికేషన్స్ ఆఫ్ గాస్ లా పైన కాన్సన్ట్రేట్ చేస్తూ వీటిపైన ప్రాబ్లమ్స్ కూడా అడిగే ఛాన్స్ ఉంటుంది. కాబట్టి ఈ ప్రాబ్లమ్స్ ఇప్పుడు దీంట్లో ఆన్లైన్లో చెప్పలేం కాబట్టి నెక్స్ట్ కాన్సెప్ట్లో ఈ విధంగా దీనిపైన ఏ విధంగా ప్రాబ్లమ్స్ అడిగే ఛాన్స్ ఉంటుందో దాని గురించి కూడా మనం ఎక్స్ప్లెయిన్ చేయడం అనేది జరుగుతుంది. సో ఇది ఇవాళ కాన్సెప్ట్. సెమిస్టర్ 5 ఫైనల్ ఇయర్ స్టూడెంట్స్ ఎస్పెషల్లీ ఫైనల్ ఇయర్ స్టూడెంట్స్ కాబట్టి ఫైనల్ ఇయర్ స్టూడెంట్స్ కంపల్సరీగా స్కోర్ చేసేటటువంటి టాపిక్ అనేది ఎలక్ట్రోస్టాట్స్. ఫస్ట్ యూనిట్ ఆఫ్ సెమిస్టర్ 5 కంపల్సరీ అందరూ కాన్సన్ట్రేట్ చేస్తూ కాంపిటేటివ్ ఎగ్జామ్ కానీ పీజీ ఎంట్రన్స్ ఎగ్జామ్ కానీ చదవాల్సి ఉంటుంది. ఓకే, సో ఇది ఎలక్ట్రోస్టాట్స్, ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ, ఎలక్ట్రిక్ పొటెన్షియల్స్, applications of Gauss law, electric potential and electric field intensity due to spherical charge conductor, due to dipole, due to line charge conductor. Okay, so these are the important questions. Must and should learn. కంపల్సరీగా చదవాలి, మంచిగా స్కోర్ అయ్యే టాపిక్ కాబట్టి ఈజీగా అందరూ గెట్ ఆన్ అయ్యే ఛాన్స్ ఉంటుంది. సో అందరూ కాన్సన్ట్రేట్ చేయండి. ఓకే, సో థ్యాంక్ యూ one and all. Thank you so much. Thank you one and all.